Howdy, welcome to Moltar Aviation. So in this video, I'm going to be talking about wind. So howdy, I'm Dr. Andy Moltar. I'm a flight instructor, CFI-IIMEI. I used to be a corporate pilot, and now I'm a professor of aviation at a university, and one of the classes I teach is aviation weather. So you're getting a free college education just watching this video on YouTube. So make sure to like, subscribe, and if you have any questions, leave them in the comment section, and I'll be happy to answer them. All right, so in this video, I'm going to be talking about wind, and I know you know what wind is, but we're actually going to be talking about it in a little bit more depth, including talking about pressure gradient force, Coriolis force, friction force, upper air winds, and surface winds. So wind is the air in motion relative to the Earth's surface. So you have air, it moves, we call it wind. And so it causes the formation, dissipation, and redistribution of weather. Wind is named according to the direction from which it's blowing. And so we would call like a westerly wind a wind that comes from the west. So if you're facing north and you feel it on your left side of your body, that's west. So you feel it coming from the west and it's blowing east. And so there's three forces that affect wind: pressure gradient force, Coriolis force, and friction force. So pressure gradient force, I know it sounds like a confusing term, but it's pretty easy to understand. So pressure gradient force is that wind driven by pressure differences, which create a force called the pressure gradient force. And areas with different pressures always try to equalize. So if you've seen my previous videos, I talked about how low pressure is a sucking force and high pressure is a pushing force. And so we identify the areas of different pressures with the isobars, or it might be called height contour gradients on constant pressure charts. And so here's an example of that. So if you don't remember, these black lines here, I'll go ahead and turn my laser pointer, but yeah, those black lines there, those are referred to as isobars, or if we're looking at a constant pressure chart, then they'd be called height contours. But either way, isobar, height contour, if you want to call them isobars, that's fine, that's what I do. But yeah, so these isobars represent areas of equal pressure. So we could call this like 1,000 millibars all along the length of this line. But this next line might be 1,004 millibars. And this next isobar might be 1,008 millibars. And then, so this is an area of high pressure and it's pushing that air outward. And so pressure gradient force, imagine this is like a topographic chart where this is the top of a mountain and this is a lower surface. If you have a ball at the very top and you let it go, what would it do? It would fall down the hill. And then, it's pushing. Now, let's say you have like a whirlpool in a lake or ocean or something, and this is where all the water is being sucked. It's the pressure gradient force is going to go perpendicular to these isobars and fall into that hole. And so this is an area of low pressure. And so this is on the left side of the picture here. It's just showing you that the pressure gradient force causes the air to move perpendicular. And that's what pressure gradient force is. Now, I want you to keep in mind, if you haven't watched any of the previous videos on aviation weather that I made, you really need to go back and watch those. I know they're very basic, but everything we learn about weather is a piece of a puzzle. And all these videos together, we're going to make a puzzle so that you'll actually be very knowledgeable about aviation weather. And if you're not watching all the videos, then, how can you make a puzzle if you don't have all the pieces? And so that's what we're trying to accomplish here, because when it comes to weather, it's not about just, the only way you can really truly understand what weather is doing is if you have a good understanding of each individual factor that affects the weather. And so you just got to kind of push through and, watch these videos. I know they're not the most exciting, but, it's just how it is. But once you'll thank yourself later if you can push yourself through, read your aviation weather handbook, which I have a link for in the description below. So, all right, we'll go ahead and go to the next slide. So forces that affect the wind. So like we said, pressure gradient force is directed from higher heights, pressure, to lower heights, pressure, and is perpendicular to the height contours, the isobars. And so wind speed is directly proportional to the pressure gradient force based on the spacing. So here on the left side of it, of this picture. These isobars are, spaced out however much, doesn't really matter, but the how close those isobars are represents how much the pressure is changing over a distance. So this is a pretty big distance and the pressure is not changing that much. And so we would call this a relatively weak pressure gradient force. But then here on the right side of the picture, you see those isobars are much closer to each other. And so that means the pressure is changing a lot. And so because the pressure is changing a lot, it's going to cause the air to move faster. And so the wind speed is stronger. All right, so the next force that affects wind is Coriolis force. So if it was if pressure gradient force was the only factor that affected wind, then it would just flow perpendicular to isobars. But that's not the case. And so Coriolis force, what it does is it actually because the Earth is rotating, so we have a flat disk. It's supposed to represent like a record player, a record on a record player. But just imagine this needle at the center is kind of like the North Pole. The edge here is the equator. And so if you're trying to draw a line from the North Pole to the equator as the Earth is rotating, you'll see that that line that you're drawing with the pencil is actually curving to the right. And so Coriolis force causes the wind to deflect to the right instead of just flowing perpendicular to the isobars, like we talked about with pressure gradient force. And so here's an example of that. So the force deflects the air to the right, and this is in the northern hemisphere. So if you're in the southern hemisphere, the wind gets deflected to the left. And Coriolis force is at a right angle to the wind direction and directly proportional to the wind speed. So the faster the wind speed, the more Coriolis force affects the wind. So here's an example of Coriolis force. So here in the northern hemisphere, remember that wind gets deflected to the right. So here in the 30 to 60 degrees latitude, as the wind is trying to move north, the wind gets deflected to the right. Okay, this wind right here, as the wind tries to move to the east, the wind gets deflected to the right. Okay, this wind right here, as it gets deflected to the south, it wants to go to the right. And as the wind wants to go to the southwest, it gets deflected to the right. And then in the southern hemisphere, like we said, instead Coriolis force in the southern hemisphere causes the wind to deflect to the left. So here's some wind trying to go to the north, but it gets deflected to the left. Some wind tries to go to the east, gets deflected to the left. So that's how Coriolis force works. And the next force is friction force. So friction force is a surface friction that slows the wind. The rougher the terrain, the greater the frictional effect. Imagine you're on roller skates or rollerblades. If you're on a nice, smooth, concrete, floor, then it's going to be very easy. But if you're on a sidewalk, you can feel how rough that surface is. You're not going to be able to go as fast. So, and the stronger the wind speed, the greater the friction. And so that's why, kids with Heelys, those shoes with skates on them, they love going to like Sam's Club or Costco where they have those nice smooth concrete floors. Makes it easy to just kind of skate along. And so, but yeah, the stronger the wind speed, the greater the friction. And the frictional drag normally decreases and becomes insignificant above the lowest few thousand feet. So above the surface layer, because then, there's no mountains, there's no, well, I mean, if there is mountains that goes thousands of feet, then yeah, it'll still affect it. But, there's no hills, trees, cliffs, things like that when you go beyond a few thousand feet. And so here's just a little picture. So on this top left picture, it is showing a weak wind. And so the weaker the wind, the lower the surface friction, the stronger the wind, the higher the friction. And then in this bottom picture, it just shows that the composition of the terrain makes an effect too. So if you're over a smooth terrain like a beach or water, you can have a strong wind with relatively low friction. But then over rough terrain, like over a mountain, you have strong wind, but then you're also going to have a lot of friction because that terrain causes that more friction. So for upper air winds above the friction layer, only pressure gradient force and Coriolis force affect the horizontal motion of air. An upper air wind initially flows perpendicular to the height contours, the isobars, due to pressure gradient force. But as the air begins moving, Coriolis force also deflects it to the right 90 degrees, causing it to flow parallel to the contour lines. So at this time, what's happening is you got pressure gradient force going perpendicular to the contour lines, but then the Coriolis force causes it to go, wants to go to the right. And so what will eventually happen here is that, Coriolis force will directly oppose pressure gradient force, and now the wind wants to flow parallel to the isobars, like so. And so when we get up aloft, then um, it's just you look at a chart that shows all the different isobars or height contours, and it shows that the wind will flow parallel to the isobars. All right, but at the surface, all three forces come into play at the surface. So as frictional force slows down the wind speed, Coriolis force decreases, but pressure gradient force will not be affected. And then their strong friction will deflect winds away from isobars. So, let's say you're over the water, the surface will cause the wind to deflect maybe about 10 degrees over the water. But if you're over rugged terrain, the wind direction can change by as much as 45 degrees. So if you're ever looking at like a METAR where it shows you the wind direction and then you look at winds and temperatures aloft, you see that there could be a big difference in the wind direction. But as you go up and up and up, then surface layer has no effect. All right, in the northern hemisphere, an area of high pressure, wind flows downward, outward, and clockwise. And then in an area of low pressure, wind flows upward, inward, and counterclockwise. Now, when you're looking locally, like within 100 miles, you really don't notice any difference, and it's difficult to tell when you're in an area of rugged terrain just because of the surface friction. But when you're looking at a big region, you're able to detect the difference a lot better. So here's an example. This top right picture. So in an area of low pressure, and if you want to look at me for a second, so here's my right hand, and so I always like to imagine I'm trying to play with a football. And so if you have your hand holding a football on the low end, and then you try to spiral it up in the air, well, what are you doing with your right hand, your fingers? So your fingers are going upward, inward, and counterclockwise. That's how air moves in an area of low pressure. Upward, inward, and counterclockwise. But then let's say you have your football and you just score a touchdown. You're trying to, spiral the ball, cause the ball to spin on the ground. Well, you grab it from the high end, and what your fingers going to do? They're going to go downward, outward, and clockwise. Downward, outward, and clockwise. So that's just how I like to remember how air flows in an area of high pressure or low pressure. There's some tricks using your hand, like you point one direction, your fingers are doing this, and your fingers up. I don't know, that's just too confusing, but I like the football reference. So yeah, that's how air flows in an area of high pressure, downward, outward, and clockwise, whereas air in an area of low pressure flows upward, inward, and counterclockwise. All right. And so here on the left, this is an upper air chart. So just showing you that air flows parallel to the isobars. And then we look at the bottom picture, we'll see that air is not flowing exactly parallel to the isobars, but because that's of the surface friction. And so in these areas of high pressure, low pressure, we have that surface friction. So it's going to not exactly flow parallel to the isobars. All right, well, that's it for this video. If you try to answer these questions, which of the three forces affect the wind? How does air flow in an area low pressure, high pressure? What's the relationship between Coriolis force and pressure gradient force? And how does the surface affect the three forces that affect wind? So if you can't answer those, go back and review this video again. But yeah, if you have any questions, leave them in the comment section. I'm happy to answer them. But yeah, so thanks for watching.